welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 8th graders out there, though all students are welcome to tune in. This lesson is the 17th in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson today. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website that I have pulled up here. You will want to scroll all the way down to Math Grade 8 to find our lesson plans and our student packet. You can still tune in to today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons, since we'll be talking about things we learned previously. Today, we will be learning about using the converse of the Pythagorean Theorem in mathematics. Before we get started today, to participate fully in our lesson, you will need paper, pencil, and a hard surface to write on. A calculator or the calculator app is recommended. Okay, let's begin. So let's get warmed up. In lesson 16, we explored this Pythagorean theorem, and this is what it told us. In a right triangle, the square of the length of the hypotenuse, C, is equal to the sum of the squares of the lengths of that legs, A and B. Many times we end up having to round some of our calculations, but there are certain sets of right triangle side lengths that are all integers. Remember that an integer is a whole number, not a fractional number, that can be positive, negative, or zero. In this case, since these values are all measurements, they will be positive whole numbers. This is called a Pythagorean triple. Write this definition down as I read it aloud to you guys, and I'm going to write it down with you. So a Pythagorean triple, let's write it underneath this. A Pythagorean triple is a set of positive integers, A, B, and C, that fits the Pythagorean theorem. This means that there are some combinations of measures that are integers and also form a right triangle. Other triangles might have integer side lengths, but that doesn't mean that the triangle is a right triangle. Let's make a list. You write some of these down with me. The most commonly used Pythagorean triple is 3, 4, 5. So let's scoop this down. 3, 4, 5. So let's check that out to see if these values fit. Which value or which one of the measures should be the hypotenuse in this set? Right, it should be the longest length if we think this is a right triangle. Let's test it out. Follow along with me. If we substitute in the values for A, B, and C, the final mathematical statement should be true. So we have A squared plus B squared equals C squared. 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25, and 25 equals 25. So yes, this creates a true statement. So since 3, 4, and 5 are integers, this set of side measures is a Pythagorean triple. Let's try another one. What happens if we change the side lengths all by adding 1 to each of these numbers? So now we have 4, 5, and 6. Let's see. Follow along with me. So we are going to test out 4, 5, and 6. If we use 6 as the hypotenuse, we get these statements. A squared plus B squared equals C squared. 4 squared plus 5 squared equals 6 squared. 16 plus 25 equals 36. 41 equals 36. Well, now this isn't true, is it? 41 is not equal to 36. Therefore, 4, 5, and 6 are not a Pythagorean triple. And in fact, although they do form a triangle, this isn't a right triangle, as we will see in our lesson today. There are many other Pythagorean triples. We can discover some as we work through the Pythagorean theorem, but for today, let's just write them down together on our list. Remember, the sets 3, 4, and 5 was a Pythagorean triple. So we have 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. Any multiple of these sets will also be a Pythagorean triple by the multiplication property of equality. So as an example, 6, 8, 10 is also a Pythagorean triple because it is a multiple of the 3, 4, 5 set when you multiply each of these terms by 2. So 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. So 6, 8, 10 would also be a Pythagorean triple. Are you feeling warmed up? Great. Let's get started on today's lesson. When we started the lesson today, we wrote down the Pythagorean theorem. And if you notice, it starts out with the assumption that you have a right triangle. Look at what we wrote down. We can actually rewrite this as an if-then statement or a conditional statement. Follow along with me. If you have a right triangle, then the square of the length of the hypotenuse equals the sum of the squares of the length of the legs. Now, in mathematical terms, the converse of this if-then statement or conditional statement is just reversing what part goes with if with the then. Let's write the converse of the Pythagorean theorem down together. The converse of the Pythagorean theorem says, if the square of the length of the hypotenuse equals the sum of the square of the length of the legs, then the triangle is a right triangle. Do you see the difference in the two statements here? In this case, the converse is just as true as the original theorem. This isn't always the case, but we can prove that both statements are true in this instance. However, in today's lesson, we are going to move ahead with the understanding that the converse of the Pythagorean theorem to determine the side lengths of a triangle form a right triangle or not. For our first example, let's determine if the given side lengths of a triangle will create a right triangle or not. Remember that the converse of the Pythagorean theorem, if the sum of the squares of the leg lengths is equal to the square of the length of the hypotenuse, then we will have a right triangle. In our warm-up, we already looked at something similar. Let's sketch a triangle and label the side lengths. Draw along with me. Now, we want to know if this triangle is actually a right triangle. So we will test this using the converse of the Pythagorean theorem. First, let's decide which values are legs and which value is the hypotenuse. In this case, we would say that the longest length would be the hypotenuse if this is a right triangle. The other two lengths are the legs. We will substitute in, and if the resulting statement is true, then this is a right triangle. Follow along with me. So we have a squared plus b squared equals c squared. Substitute in 9 and 40 for the leg measures and 41 for the hypotenuse measure. Now simplify both sides and determine if the resulting statement is true or not. You can use your calculator or a calculator app with the arithmetic if you'd like. And as I stated in our previous lesson, I'm going to be using a student calculator. However, you may not have one of those available for you. So I was going to show you what that would look like in your calculator on your phone. If you have an iPhone, you'll want to make sure that the orientation lock is off. And if you just turn it to the side and we want to square a number, just type in like 9, and then you're looking for the button that has an x squared, and that will tell you what that answer is. Okay, so that's an option for you. I, however, am going to be using a student calculator. 9 squared, which is equal to 81, plus 40 squared, which is equal to 1600. And then we have 41 squared, which is 1681. So 81 plus 1600 is 1,681 is equal to 1,681. So we can see that this statement is true. Therefore, a triangle with side lengths 9, 40, and 41 is a right triangle. Bonus question. Think back to our introduction. What else can we say about 9, 40, and 41? Did you say that 9, 40, and 41 are a Pythagorean triple? Then you're right, because 9, 40, and 41 are all integers that create a right triangle. Great work. Let's think about a second example. You can draw a sketch if you'd like. Here are the side length measures of a triangle. We have 8 inches, 12 inches, 8 inches, 10 inches, and 12 inches. Which measurement would be the hypotenuse and which measurements should be the legs? Did you decide that the hypotenuse should be 12 inches and that 8 and 10 should be the leg lengths if this is a right triangle? Great, let's test this set out. We will substitute in and see if the resulting statement is true. Follow along with me. So we have a squared plus b squared equals c squared. 8 squared plus 10 squared equals 12 squared. Now simplify both sides and determine if the resulting statement is true or false. You can use your calculator or your calculator app to help you with the arithmetic if you like. So I've got 64 plus 100 equals 144. 164 equals 144. And this is a false statement. So we can see that this statement is not true. Therefore, the triangle with side lengths 8, 10, and 12 is not a right triangle. Another bonus question for you. Is this a Pythagorean triple? Did you say no? Then you're correct. Even though these side lengths of a triangle are integers, they are not a Pythagorean triple because they do not form a right triangle. Let's think about this problem. I'll read it aloud and you can sketch the situation. A blueprint for a triangular playground shows that the side measures 480 feet, 140 feet, and 500 feet. Is the playground in the shape of a right triangle? Did you sketch a model something like this? As before, let's use the converse of the Pythagorean theorem to help us answer the question about whether or not this is a right triangle. Like in the other two problems, we need to decide which length could be the hypotenuse and which lengths could be the leg measures if this is a right triangle. You can already pretty much see that by the diagram, but yes, the leg lengths are the two shorter measurements, 140 and 480, and then the hypotenuse measure would be the longest length, or 500 feet, as we can see in both of these examples. Now we are ready to test to see if this is a right triangle. We will substitute in and see if the resulting statement is true. Follow along with me. So we have a squared plus b squared equals c squared. We're going to substitute in 140 and 480 for the leg measures and 500 for the hypotenuse. Now simplify both sides and determine if the resulting statement is true or false. You can use your calculator or your calculator app to help you with the arithmetic if you'd like. So I have 19,600 plus 230,400 equals 250,000. So I'm going to add those two together and I get 250,000 is equal to 250,000, which is a true statement. So we can see that this statement is true. Therefore, a triangle with side lengths 140, 480, and 500 is a right triangle. Great work. Now let's practice a couple more. I'm going to walk you through another example, look at the diagram, and make a sketch on your own paper. Our question is still whether or not these three sides will form a right triangle. First, we determine which length to use as the hypotenuse and which lengths to use as leg lengths for our test. What do you think? Right. 18.5 is our hypotenuse for our test because it's the longest measure and it's across from what appears to be a right angle. The other measures, 6 and 17.5, will be the leg measures. We will substitute in and see if the resulting statement is true. Follow along with me. So I have a squared plus b squared equals c squared. Substitute in 6 and 17.5 for both of the leg lengths and 18.5 for the hypotenuse. Now simplify both sides and determine if the resulting statement is true or false. So I get 36 plus 306.25 equals 342.25. I'm going to add these together, and when I do, I have 342 and 2500 is equal to 342 and 2500. So this is a true statement, and that means that these measures do form a right triangle. Are the measures also a Pythagorean triple? If you said no, then you are correct. Although they do form a right triangle, the measures are not integers. Let's work on another set. I'll read this problem aloud and you can sketch a model and label the sides. Listen to the problem. Let's scoot this down. A mosaic consists of triangular tiles. Most of the tiles have side lengths 6 centimeters, 10 centimeters, and 12 centimeters. Are these tiles in the shape of right triangles? I'll read it one more time for you while you finish your sketch. A mosaic consists of triangular tiles. Most of the tiles have side lengths 6 centimeters, 10 centimeters, and 12 centimeters. Are these tiles in the shape of right triangles? Does your sketch look something like this? What do we need to do first in order to test these measures to see if they form a right triangle? Right. Determine which lengths would be the leg measures and which one would be the hypotenuse measure. You take a second and decide that. Did you choose 12 centimeters as your hypotenuse? Good. It's the longest measure, and the other two will be our leg lengths. Now, we've done several of these already. Take a minute to see if you can set this up and test it on your own. Did you start it out this way? A squared plus b squared equals c squared. Substitute in 6 and 10 for our leg lengths and 12 for the hypotenuse. Now simplify both sides and determine if the resulting statement is true or false. As before, you can use your calculator or calculator app to help you with the arithmetic, but you may not need it with this one. I'm going to give you a second to finish. Do your final statements look like this? 36 plus 100 equals 144. So I have 136 equals 144, which is not a true statement. So what is the final answer to the question? Exactly. The measures 6, 10, and 12 do not form a right triangle. You're definitely ready to tackle these on your own. Here's one more for you to look at. Here's a diagram. I'll give you some time to work through this one by yourself to determine if these side lengths form a right triangle. Well, what did you decide? Yes, these measures do form a right triangle because this statement is true if you used 1.25 or 1 25 hundredths for the hypotenuse. So we're going to start with the Pythagorean theorem, and we're going to sub in our values for our leg lengths and for our hypotenuse. And we're going to simplify both sides. So when I do that, I get 1 plus 0.5625. One more quick bonus. Are these measures a Pythagorean triple? If you said no, then you are correct. They do form a right triangle, but the measures are not integers. Here's another example. Let's determine if these side lengths of a triangle are right triangles. So we have 12 feet, 35 feet, 37 feet. As we've done previously, we will use the converse of the Pythagorean theorem to determine if these measures form a right triangle. What do we need to do first? Right, determine which length would be the hypotenuse if this is a right triangle. Which one of these do you think it should be? Did you say 37 feet? That's correct because it's the longest measurement of the set. So by the converse of the Pythagorean theorem, the sum of the squares 12 and 35 should be the same as the square of 37 if this is a right triangle. Let's test it out. Follow along with me. So I'm going to start with the Pythagorean theorem. I'm going to substitute in 12 and 35 for my leg lengths and 37 for the hypotenuse length. Now to simplify both sides and determine if the resulting statement is true or false. As before, you can use your calculator or calculator app to help with the arithmetic, but you might not need it on this one. I'll give you a second to finish. Did your final statements look like this? 144 plus 1,225 is equal to 1,369. 1,369 is equal to 1,369. This is a true statement. So what is the final answer to the question? Exactly. The measures 12, 35, and 37 do form a right triangle. Here's one more example. Listen as I read the problem and make a sketch on your own paper. Savannah is an artist making a triangular base for a piece of artwork. The triangle she made measures 63 centimeters, 60.5 centimeters, and 87.5 centimeters. Is this triangle a right triangle? I'll read it again while you finish up a sketch. Savannah is an artist making a triangular base for a piece of artwork. The triangle she made measures 63 centimeters, 60.5 centimeters, and 87.5 centimeters. Is this triangle a right triangle? Does your sketch look something like this? Yours might look a little different, but as long as you have the three sides labeled 63, 60.5, and 87.5, then we're good to go. Now let's use the converse of the Pythagorean theorem to help us answer the question about whether or not this is a right triangle. First, decide which measure is the hypotenuse if this is a right triangle. What did you decide? I picked 87.5 centimeters because it's the longest side, and I hope you did too. Now the other two measures should be the legs. Follow along with me. And we're going to substitute in 60.5 and 63 for our leg lengths and 87.5 for our hypotenuse. Now simplify both sides and determine if this statement is true or false. I'll give you some time to finish. Did your final statements look like this? We have 3,660.25 plus 3,969 equals 7,656.25, which gives us 7,629.25 is equal to 7,656.25, which is a false statement. So what is the final answer to the question? Exactly. The measures 63, 60.5, and 87.5 do not form a right triangle since the sum of the squares of the legs do not equal the hypotenuse of the longest side. All right, guys. So after this lesson, you guys know where to find some additional problems to practice on your own. On our Tennessee Department of Education website. I enjoyed exploring the converse of the Pythagorean theorem with you guys today. Thank you so much for inviting me into your home, and I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Goodbye.